All right, today's lesson is on a thing called torque. And torque is a force, but it's not just any old force, it's a force that causes rotation. All right, so in your notes, you've got this. Alright, so torque is force that causes a body rotation, sometimes it's referred to as turning moment. Torque is a vector quantity. Alright, so because force is a vector, it operates in a particular direction. So torque will also cause the body to rotate in a particular direction. And so clockwise is negative. Alright, so the thing you need to remember is clockwise is negative. And so torque, in the little Greek letter tor, is RF sine theta. Alright, so F of course is the force, R is the actual distance that the force is being applied from the point of rotation, and angle, theta is the angle that the force, angle between the force and, oops, sorry, wrong arrow. So the angle between, theta is the angle between these two things. Alright, so here's a diagram in that shows that, and also the definition. Alright, there it is. You've got that in your notes. Alright, so F is the applied force there, R is the distance between where the force is being applied and where the thing rotates, and theta, this angle in here between the radius and the force, the angle between them. Alright, so the unit, so if torque is RF sine theta, alright, so sine theta is just a number, that's meters, that's Newton, and so torque just combines those, so meter Newton. Alright, MN. Alright, so later when we get to work in energy, there's something that's similar to that, but it's important to remember though when we're talking about torque, meter Newton is the one we have to use. It talks about particular application of it. Alright, so meter Newton, torque. Let's have a look at some examples. Okay, a woman whose car has a flat tyres, two wheel nut spanners in the boot. One wheel spanner is 15 centimetres long and the other is 75 centimetres long. In order to undo the wheel nuts with minimum amount of effort, which wheel spanner should the woman select? So remember that torque is RF sine theta. So in this particular case, we're really focusing in on the radius and the force. So if we're thinking about minimum amount of effort, you know, the effort is the amount of force we've got to apply, and the wheel nuts will require the same amount of torque. So we want that to be low as possible. So how we're going to get torque, the other things we've got is these two, one's 15 centimetres and one's 75. Alright, so if the longer the one that we've got, that's going to make the torque larger. So which wheel spanner should she pick? She should pick the longer one. All right. And earlier in junior science, would have done some lever kind of stuff. So this is like the technical aspect of the lever. So a longer lever means it's less effort for you. So the same thing here. The reason as to why is because of the torque. Okay. So a longer lever, you don't need to apply as big a force for the same torque. All right. So part B, the maximum force the woman can apply is 45. Determine the maximum torque that can be delivered to the wheel nut. All right, so for B, remember torque equals RF sine theta. Now, R we've just figured out in the previous part, the longer one, so 75 centimetres. So R is 75 centimetres, which is 0.75 metres. The force that she can apply is 45. It says the maximum force she can apply. The question here is sine theta. All right, now, from what we know about sine, cos and tan, is that the maximum value of sine theta is equal to 1 when theta equals 90 degrees. All right, and so we want the angle to be at 90 degrees. Because if we go back here, one more, see how this one here, the angle's not at 90 degrees, so when we break this up into components, the green component's trying to push this way, whereas the orange one's pushing that way to rotate. All right, so we want 90 degrees. So when we do that, our torque is equal to 0.75 times 45 times sine 90, and when you multiply that on your calculator, you get 33.75, which seems everything here's just got two figures in it. We'll round that, 34 metre Newton. All right, one more example. Okay, mechanic uses a 17 centimetre long spanner. To tighten a nut, he applies a force at an angle of 75. Calculate the amount of torque. All right, so as we know, torque equals RF sine theta, and the radius here is 0.17 metres. Remember, it's got to be in metres. Force is 104 sine, and it says the 75 degrees is the angle. You put all of that in your calculator, and you get 17.1 metre Newton. All right, so that's it. That's torque. All right, so not force. Remember, torque is a force that makes things rotate. All right, so spanners, opening doors, all of that kind of stuff is related to the torque thing. All right, and there's a couple of videos to watch, and also as always, if there's anything you need me to clarify, make sure you ask.